Okay, in our last example, we found the amount of work done by a constant force, and right now we're going to find the work done by a variable force. Now there's different kinds of variable forces. In this case, we're going to look at a spring, which follows Hooke's law. So that's the force required to stretch or compress a spring. So a spring, the farther you pull it, the more difficult it gets to stretch, or if you compress it, it gets more and more difficult to compress. So it's a variable force. We're going to use the formula Hooke's law as F force equals K times D, where K is the constant of proportionality, or sometimes it's called the spring constant. And so here we go. We've got what we're going to do is we're going to take the work is going to equal the integral from a to b of f of x dx. Okay, so in this problem, a force of 750 pounds compresses a spring 3 inches from its natural length of 15 inches. Find the work done in compressing the spring an additional 3 inches. Now you got to be really careful here because people screw this up all the time. It's an additional 3 inches, so you got to integrate over the right area. The first thing we got to do is we got to figure out, since we don't know anything about this, we need to figure out what the constant of proportionality is. So we know that f of x equals k times d. Okay, and d is distance, k is the constant of proportionality. So we're going to go ahead and substitute 750 because we know we took that much force to compress it 3 inches. So we get this, and then we divide both sides by 3, and we get k equals 250. So there's our constant of proportionality. The next thing we're going to do now is we are going to set up our problem. So the work is going to be the integral. And remember, the first 3 inches took 750 pounds. Now we want to do an additional 3. So we're going to integrate from 3 to 6 inches here. And that's going to be 250 x dx. Okay, so we can pull the 250 out and just integrate from 3 to 6 of x dx, and that's super easy to do. That's going to be 1/2 x squared evaluated from 3 to 6. Okay, and then that's 125 when we multiply that in there, evaluated from 3 to 6. And so we plug in 6 and 3, and that comes out to be 4,500 on the first one, minus 1,125, and that comes out to be 3,375, and our unit is going to be inch pounds, because it took pounds of pressure, which we get from right here, and we measured in inches, which we get from right there.